So on this problem, for the given polynomial functions, we're going to do a few things. We're going to state the degree, find the zeros and give their multiplicities, and state if the graph crosses or touches and turns at each zero. So the first thing we want to do is state the degree. So this will be part A. When we're doing this, all you have to do is add all the exponents together. So here we have degrees of ones that are happening inside. So we know this is just a degree of 2 plus this one also only has a 1 inside, so here we have a degree of 3, because 2 times 1 will get us 2 and 3 times 1 would get us 3. So 2 plus 3 is equal to 5. That's the degree of our function. The second part is finding the zeros and their multiplicities. Well, the nice part about this problem is it's already factored for us, so we don't have to factor. We're just going to take each part and set it equal to 0. So, and you don't need the parentheses. So here we're going to subtract our 6 over, so we get x equal to -6. And here we will add the 6 over and get x equal to 6. We don't have to worry about the coefficient up front. There's not an x there, so it's just a coefficient. It has nothing else we can do with it. So now these will be our zeros. That's the first few. The other thing we have to do is figure out what's happening. So for each zero, so that was find the zero and their multiplicity. Here's the multiplicity part. This one, it came from here, so the multiplicity will be equal to 2. On this one, the multiplicity will be equal to 3, because you're pulling the coefficient off of each one. Now, on C, we have to state if the graph crosses or touches and turns at each zero. So remember that if it's an even degree or multiplicity, then it will do, it's like a 2. Even is like a number 2. So this will do two things. This will touch and turn. Now if it's odd, like a number 1, it does one thing. And this will be, it crosses. And we're talking about the behavior over the x-axis, because these are zeros. These are basically X-intercepts. So on this one, we will have it, because it has an x equal to -6 with that multiplicity equal to 2, we know it's going to do two things, and those two things will be touch and turn. On this one, we have x equal to 6, and we have our degree or our multiplicity of equal to 3, so that makes it odd, so it'll do one thing. This one crosses. Okay? And that will go the same way for any of them, even if you're if you have 2, 4, 6, 8, or 1, 3, 5, 7, 9, 11, and so forth. They will always do either two things or one thing. The next problem that we are going to look at is graphing the polynomial function, and we're going to do 4 things on this one. So here is our next problem. We are determining the end behavior, finding the X-intercepts, which are our zeros, and the Y-intercepts, determining the behavior at each zero, and finding the maximum number of turning points of the graph. So the first thing we're doing is figuring out the end behavior. So remember, we're looking at the leading coefficient again. Remember, I'm going to write that as LC. Is it positive or negative? The number does not matter. It's just if it's positive or negative. We can see there is only positives happening here on our x's, so this will be positive. The next thing we want to know is what's the degree, because that tells us what our ends do. Do they go the same direction or opposite? So to find the degree, we're going to add all of our exponents. So this will get us 1, because whenever there's nothing written there, it's going to be 1, plus 1, because there's another one, plus 2. So 1 plus 1 is 2, plus 2 will equal 4. Well, that tells us this is an even degree, right? So even tells us that it's a parabola, and parabolas go the same direction. Because it's positive, it's going to open up. So that will be our end behavior. This will help us when we go and graph our polynomial because we know where our ends are going. The second part that we're going to do is B. We're going to find the x-intercepts or zeros and the y-intercepts. So thankfully, this is already factored, so we don't have to do that. So we're looking at x plus 1 is equal to 0, x plus 3 equals 0, and x plus 5 equal to 0. So we're going to solve each of these. So we'll get x equal to negative 1, minus 3 will get us x equal to negative 3, and by subtracting 5 from both sides, we get x equal to negative 5. So these zeros or intercepts are going to look like negative 1, 0, negative 3, 0, and negative 5, 0. It's good to go ahead and make them points so that you remember what those mean. You don't have to try and remember and figure that out because these will be x-intercepts on our graph. Now to find our y-intercept, remember we always set x equal to 0. F of x is the same thing as y, so we will have y is equal to, instead of putting x, we're going to place our zeros. So we'll have 0 plus 1 times 0 plus 3 times 0 plus 5 squared. Well, that's going to get us 1 times 3 times 5 squared. Well, 1 times anything is just going to be whatever number it is. So we've got 3 and 5 squared will be 25. So in this case, our 3 times 25 is going to get us 75. So that's a y equals, so this will give us the value of 0.75. That will be the y-intercept. All right, the third thing that we need to do was to determine the behavior at each zero. Well, at this 0 here, we have x equals negative 1, and our degree on that, we had a degree of equal to 1, which is the same thing as our multiplicity, right? Multiplicity and the degree are the same. So because of that, we are going to know that this is going to cross. Remember, we talked about how if it's an odd degree, it crosses. On this one, we also have an odd degree. We have a degree which is equal to 1, same thing as the multiplicity. So therefore, this is going to cross also. And on this one here, our degree is going to be 2. So you can see this as a degree or multiplicity. It does not matter either way. So 2 being even does two things, right? So this will touch and turn. All right, so the last thing that we need to do is find the maximum number of turning points of the graph. Now, and let me clarify on here, when we're talking about this behavior, we're not looking at what happens at the y value because that's not the zeros we're looking for. That's a y-intercept. It's not the same as the x-intercepts. All right, so D is the maximum number of turning points of the graph. The formula for that is n minus 1. And the n is the degree. So another way to look at that is the total degree, so the degree of the entire function minus 1. So our degree here was 4, so we're going to go 4 minus 1, which will get us 3. That tells us the maximum number of turning points on our graph will be 3. It's always going to be 1 less than your total degree. All right, so we're going to graph this. We've got our x, we've got our y. For the most part, our numbers are not that big. Our 0.75 is really big, and we'll just kind of make a guesstimation on that. 3, 4, 5. Do your best to make your graph evenly spaced. If we're going to have a positive, we're going to kind of call that 75 up there because we don't want to make 75 hash marks. All right, so we're looking at plotting all of our points. We've got negative 1, 0. We've got negative 3, 0, and negative 5, 0. We've got our y-intercept up here. Now, what's happening with our end behaviors? Well, we know that we had both of them going up. So we know that the graph is going to come in this direction and go up this way. And we know that this last intercept is going to also come up and it'll cross through our y-intercept. Now, what happens at each of our values? Well, at -5, which is this one here, we have degree of 2, so it's touching and turning. So we know it's going to come down, touch it, and come back up. And then we know on the -3, x equals to -3, it's crossing. So we're going to come back through and cross. And at the -1, we also know it's going to cross. So we're going to come back up. It may go farther, but remember, we're sketching. So you could have drawn your loops a little bit bigger. It's up to you. But we're just doing a sketch of the graph.